Hi, so this is question 2B of the Lincoln High School Level 3 Probability Practice Exam 2015. So we're told that the local hairdressers does an anonymous survey of its customers, and they give us the results. And then we're asked, are the events being served by Terence and being happy with the service received mutually exclusive events? Okay, so we need to remind ourselves, what does mutually exclusive mean? Now, a lot of people had forgotten what mutually exclusive meant. Well, if two events are mutually exclusive, it means that they mutually exclude each other from happening. If one happens, then we know the other one doesn't happen. An example is school houses. So at our school, if we know that you're in Inaka House, then we know you're not in Mako House. Being in Inaka excludes you from being in Mako because you can't be in both houses at the same time. So if I pick someone at random from the class, the probability that they are in both Inaka and Mako is what? It's 0. So if two events, we'll call them A and B, are mutually exclusive, then it means that the probability of A and B, which we write like this, equals 0. And also, within a particular group of data, if we find out that the probability of A and B is 0, then we can conclude that those events A and B are mutually exclusive. So the arrow goes both ways. So let's apply that to the situation. The events here are being served by Terence and customer being happy with the service. So I'm going to call being served by Terence, I'm going to call that T, and I'm going to call happy with the service H. And so what we're testing for here is whether the probability of both T and H happening is 0. So how should we represent the information from this question? Well, when we are doing that with probability, the first one to consider is a two-way table, because usually that's easiest. So go with a two-way table if you can. 90% of the customers said that they were happy with the service they received. So probability of H is 0.9. 8% of the customers responded that they had had their hair cut by Terence. So probability of T is 0.08. And 3% said they were not served by Terence and were not happy with the service they received. So probability of not T and not H equals 3%, 0.03. Now, we can definitely use a two-way table here because there's only two category variables here, whether you were served by Terence and whether or not you were happy. So we don't need a three-way Venn diagram. We don't need to resort to a tree diagram either because none of these probabilities I've written down here are conditional ones. Okay, they're all out of the total. So as long as that's the case, we can use a two-way table. So let's do that. So the first question is whether or not the person was served by Terence, T or not T. And then the next question is whether they were happy or not, H or not H. And we can just start filling it in. So why don't you pause the video, and if you haven't already done this table during the exam, do it now on a bit of paper. And then see if you can answer the question. Only hit play once you've had a go, and then just see whether you got it right. Okay, so I'm assuming you've had a go by now. So I'm putting in the 0.9 as the total for H, the happy people. So 0.9. Grand total has to be 1. 8% was served by Terence, so 0.08. And that means, what else? 3% were not served by Terence and not happy, so that's going to be the no cell. No and no, and then we can fill in the rest from there. Like so. Now, sometimes it's actually easier because we think easier to write these as percentages rather than decimals, just because we think more easily in percentages. So you could do that as well and make it out of 100, like this. And that's a wee bit easier, isn't it? Okay, so the question was, are the events T and H mutually exclusive? Well, remember the test is it possible for both of those events to occur in this data set? And yes, it is, because the probability of T and H is 1%, not 0%. So, are they mutually exclusive? No, they're not mutually exclusive. Specifically, being served by Terence and being happy with the service are not mutually exclusive. And what's the evidence? Well, the evidence is that the probability of T and H is 0.01, not 0. Meaning that just because you were served by Terence doesn't mean that you can't be happy with your service. Right, next question. Should Terence's boss be concerned with the results of the survey? Justify your answer with statistical statements. Well, when we're asked a question like this, it's aiming at relational thinking. So it's wanting us to compare the probability of someone being unhappy if they were served by Terence with the probability of someone being unhappy if they were served by someone else. A few people tried to do it by just pointing out the fact that most people served by Terence were unhappy, but you had to compare that as well with the people who were not served by Terence. So if we just look at those served by Terence, so amongst those served by Terence, it's a good starting point. So it's out of 8%, and we can see that most of them weren't happy. So that doesn't look good for Terence, does it? 7 out of 8 were unhappy. So how do we write that? Well, let's just start with the obvious. So most of those served by Terence were unhappy. And specifically, 7 out of 8 were unhappy. So how do we write that? Well, let's just start with the 7 out of 8. So 7 out of 8, which is what? Well, it's 0.875 or 87.5%. So how do we write that using notation? Because we need to be doing that. We need to be getting comfortable with that. Well, P for probability, the probability that given person was served by Terence, they were unhappy. H dash means not happy, remember? So that's the 7 out of 8. Okay, now we need to compare that with those who were not served by Terence to see if he's actually doing a worse job than the others. So in comparison of those not served by Terence, and we need to look at the information. So the other 92% were not served by Terence. And if you look, only 3 out of those 92% were not happy. So that's pretty damning on good old Terence, isn't it? Sadly. So 7 out of 8 of Terence's customers were unhappy compared to only 3 out of 92% of the rest of the customers. So in comparison of those not served by Terence, a very small percentage were unhappy, a much smaller percentage. And we look specifically at the numbers, so it's 3 out of 92. So 3 out of 92, which if we get that as a decimal or a percentage, 3 divided by 92, so only 0.0326, so only about 3% were unhappy of those served by other people. So we're talking 87.5% versus 3.26%. And the notation for those not served by Terence, so probability given that you were not served by Terence, so T with a dash, that you weren't happy, is much lower. So taking a step back, what's the goal of the problem again? Should Terence's boss be concerned? Yep, certainly should be. So the answer to the question is, so yes, Terence's boss should be concerned because a much higher proportion of Terence's customers were unhappy than other people's customers. And if we wanted to get a bit of a number on that, the relative risk of being unhappy if you were served by Terence compared to being served by someone else equals, and we go the risk of being unhappy if you're served by Terence, which is 0.875, divided by the risk of being unhappy if you were served by someone else, which is 0.0326. So again, 87.5% divided by 3.26%, and 26.8 times more likely to be unhappy if you were served by Terence. So customers served by Terence were nearly 27 times more likely to be unhappy. Wow. Time for a major performance review for poor old Terence, I feel. Okay. So we've showed relational thinking here, haven't we? How have we showed relational thinking? Well, we've related the risk of being unhappy if you were served by Terence to the risk of being unhappy if you were served by someone else. And then we've used that to solve a problem, which is to identify whether Terence's boss should be concerned. So that's going to be a merit level, isn't it? So if we look at how it was marked, so we see that the bit about mutually exclusive, that was the first part one, was up to merit. If you just got as far as a diagram that had some probabilities on it, so even just getting started, that already gave you evidence towards achieved. So if you wrote nothing, you got nothing, but if you had a go, at least it gave you something towards achieved. And then for merit, you just needed the correct statement made. So no, they're not mutually exclusive. And also you need a justification. So you needed that probability of being served by Terence and customer happy being equal to 1%, not 0%. For part two, it says for merit, a statement is made about his boss that is backed up by numerical values. So if you didn't back it up with numerical values, then you wouldn't have got it. And specifically when we marked it, we were actually looking at comparing the conditional probability. So the way I did it, I looked at the probability of being unhappy and compared that with those that were served by Terence and those that weren't. You could have also done what they've done here and done it for the other way around. So the probability of being happy given that you were served by Terence versus being happy given that you were not served by Terence, and that would have been just as good. And so you're 7.7 times more likely to be happy if you were not served by Terence. So all the best. It's worth practicing a few of these. And if you have the D&D books, they're good. Otherwise, past exam papers have lots of questions like this.